everyone. Thank you, Ivan, for the presenting my name and title. And my playful name of the presentation is aimed at talking at AI, machine learning, computer vision, and how all those terms relate to each other and are interconnected. When you turn on the TV and your video provider recommends the movie to you, it's AI. If you use a search engine, put something there and see the results and the tooltips and hints, then it's AI. So it's all over throughout our life. And if you look at what has led to the renaissance of AI, then we need to mention that AI is not just something new. It took thousands of years for AI to mature, since 1950s maybe. Then we had a number of eras and breakthroughs, but one of the things that I see as a big breakthrough is computer vision, and of course, as I am doing computer vision, it gladdens me a lot. And as Andrew has said, let me repeat it: in 2013, the breakthrough in the computer vision Olympics, many problems of semantical connectedness and others were solved. So let me illustrate the connection between machine learning and deep learning, like pedestrian detection, for example. To the left, a couple of screens are done by ML, and to the right, the pedestrians were done through deep learning. So obviously, deep learning gives us significantly more accuracy, and it solves the task that is not solvable by ML with partially overlapped people, for example. So let me tell you a couple of things about the industrial trends, at least the things we see. So with that AI spring, we hear a lot of things about AI taking the jobs from people and everything being replaced by machines. But according to the analysis, by 2030, the AI will give at least 13 trillion of additional economic activity. And besides that, there will be 58 million new jobs created by AI. Thus, AI will positively influence what will happen in the economy. If you look at how the applications and technologies of AI will grow, then in general, the market revenue for AI will grow to $120 billion, which is a huge amount of money, and it illustrates that AI has been adapted by to all of the industries and adopted in most of them. Another big issue of AI is the data issue, because they are exponentially growing, and in 2020, all the video cameras in the world were generating 2.5 thousand petabytes a day. If you think it over, the amount of cameras is significantly more than the amount of people on Earth, and currently I saw a 60K censored camera, and thus the amount of data it gathers is of course growing super fast. This leads to the fact that you cannot actually put all that data from the devices to the cloud, and we need to accept it as something we cannot change, that we will need some edge computing. So part of the data, or all the data, will be processed by the devices or the servers close to those devices. And in 2019, about half of that data was processed there, and this is growing. AI is an interesting area. And what has happened in the last 8 years has enabled us to start doing things that were. A couple of words about the democratizing of AI. If you look, starting 2012, the research and early innovations period, then till 2018 you have early adoption, and the training is roughly the same as inference. It means that there's not much deployment and there's a lot of experiments with people playing with the networks, choosing the topology. And during that period of time, the training frameworks, proprietary training frameworks are being developed, and the development and deployment, and even the data, except for a number of public data sets, are proprietary. And since then, we have moved to a mass deployment, and inference starts to significantly be significantly bigger than training, and now we see the democratization of AI in opening the training networks. And but still, the deployment tools are still proprietary, and most of the data is still proprietary. We, as a company, and my team specifically, as already said, we were part of Vinci's company, and we worked a lot with OpenCV library. And we do believe in open source, and we like open source a lot. Thus, Intel, as a company, because of our influences, invested in democratizing of the deployment of AI. And we have created an OpenVINA tool that is fully open sourced with a very simple Apache 2.0 license and has been developed in open source. We will have Anna Belova's presentation about that, but what I would like to highlight is that OpenVINA is fully open and it supports to integration with third-party hardware platforms. Couple of examples from healthcare that would have been impossible without deep learning or AI. If you look at 2020, it was very tough because of COVID-19, but healthcare specifically has started growing and developing much faster than it was before because of that COVID-19 influence. And in healthcare, AI has shown the biggest growth out of all the industries in terms of the modalities and in the illness analysis. So for healthcare, AI is, well, I don't know how to put it into Russian, is a bridge to the new age. Telemedicine has developed more in the last year than it has in 20 years plus. And moreover, COVID-19 pandemic has shown all of us that we need to share data and enable federated learning. Couple more examples. In China, a couple of years ago, we had a contest between different companies and their models about the brain tumors and their ability to diagnose them. So the group of people from different universities has trained a number of different models, 15 of them, and they had very good doctors, but in both cases, the hematoma expansion also, the system has beaten even the top doctors. And we were not talking about the group, if it would not be for the groups of doctors competing against AI, then the difference would be even bigger. So yes, definitely AI can affect this positively, and it should be used in a broader way in practice. So if you have that's for cases when you have that sparse signal, you can recreate it. And here's an example of what we do 5 times faster than with other case. In terms of computer tomography, this can mean a real lot. Another example from MRT and MRI. Together with GE, we can recreate the picture with the accuracy that does not depend on your position or whether you move or not in the MRI machine. And another example that has happened a couple of days ago, on Monday, Ivan has mentioned the DeepMind company and their AlphaGo. Here we have another example with AlphaFold, with more than 50 years of development and challenge in biology to predict how the proteins would behave and their structure. So this task was solved using AI, and this will enable the scientists to create new drugs and understand different diseases significantly better. And let me now spend a couple of minutes talking about the myths of AI and myths of deep learning. One of those most fundamental myths is the story that says, well, if you want to do those things, you need a GPU. That's not true. And if 7 to 8 years ago, the image sizes were 244 by 244. Then this went into healthcare and oil and gas. Now, currently, the sizes, the data set sizes, are much bigger. They are usually 3D, they're usually high bit rate, and they're much, much bigger. So with this example, I wanted to show you the inference times for single computer tomography scan, and I'm comparing the most powerful NVIDIA processor with quite a usual Intel Xeon processor. So it's just only 2.5 times better than the cheap CPU. This has to do with the fact that the GPU memory is limited and CPU memory is pretty much infinite. So with those huge data sizes that start to creep into different industries and classes of tasks and problems, this becomes even more of an issue. People think also that deep learning looks a lot like a brain works, or works a lot like the brain works. I would not be so sure. I'm father of 4, and my youngest one is 1.5 years old, and I have spent a lot of time with him, and I have never shown him 100,000 of the pictures of an eel. We had maybe 1 or 2 pictures in a book and never saw a real animal in the real life, and 1 or 2 pictures were enough for him to be able to recognize the real animal. So we as humans, we don't analyze features. We don't train by hundreds of thousands of images. Everything that has a number of legs and so you can use to sit on is a chair. So we use different heuristics, and the picture to the left has some sense for us. The picture to the right probably not, because of the gravity laws. On this picture, we see as grown-ups at least, we would definitely say that the weight will go down and the athlete will probably also fall. No artificial intelligence system will be able to predict this based on one picture. Thus, when you humanize the deep learning or AI to such an extent and start to compare it with how people learn. To me, it's a mistake. One more thing, I've already mentioned that the complexity of models and consequently complexity of the data sets grows by a factor of 10 every year. GPT-2 in the beginning of 2019 had 1.5 billion parameters. GPT-3 in the mid-20s was 175 billion parameters. So it's more than 100 times difference. And these data set, the bigger the data set is, the bigger the model is, the bigger the computer you need. And one more thing, my last slide. I wanted to start kind of a discussion here. Training of an NLP pipeline generates the amount of CO2 emissions of the same size as 5 cars emit in their lifetime. So think about it. This is the carbon footprint of the deep learning. So if each and every researcher of AI would train an NLP pipeline, this would create a 5 million cars comparable emissions. And the issue we have in front of us is quite serious. What should we do here? Should we train those models based on huge data sets? Should we make them shared? Should we make them open, and so that each and every company would merge the training process and use the subsets? I think we need to move to different architecture of networks with more information density. Other issue is the small data sets, small data. Thank you, Alexey. While we wait for the questions from the audience, one question from my side. You said that you were able to, you joined Intel recently, so this is obviously interesting to each and everyone. And we see AI growing, the conference on AI becoming more and more interesting and popular. And I would like to ask you, so how do you handle that huge, at least supposedly huge, interest to contribute to your platform by the open source community? Can you aggregate all those ideas and different positions and things that people offer you in one code base? Answer: well, that's the same as with OpenCV, actually. It takes a non-linear amount of time to gather the audience. OpenCV library, created by Intel and open sourced in around 25, was caught up by NC since we started supporting it. And originally it was just 2 researchers managing that. But when we saw embedded, when we saw mobile, the exponential growth of the audience and the interest has happened, and from one engineer supporter, we have now grown to at least 10 people in Intel supporting it, supporting the OpenCV. So we expect the same for OpenViva. We have open sourced it roughly a year ago. We saw the first contributors within the first month, and the things that people bring in currently are just ready-made patches. We look them through and we apply them. It's the same as it happens with OpenCV. We keep developing the platform, and we have more than 100 people developing it. And the contribution by people is maybe, well, we have 2 to 3 people merging it with the platform and with the code base. And I, of course, would very much like to see within the foreseeable time frame more than 100 contributors actively working on the platform, so that we have the comparable contribution of open source and proprietary growth. So, and if we have 10 times more people, then it will be a great success, because when the community develops the product and is actually responsible for its roadmap, then that's a dream, and that will mean for me the democratization of the AI tool set. And if it covers the broad spectrum of both hardware and software, that would mean for a developer that you just write the code once. Okay, yeah, sorry, Alexey, we have to